Okay, so today we continue this one. Okay, the convolution theorem. Convolution theorem. We start the class now. Convolution theorem is used for inverse Laplace. Okay, for inverse Laplace. So when we want to inverse a Laplace function, and the function is a product function, okay, product function f times g, then we can inverse Laplace by using this formula. Okay, so this formula involves the integration. Okay, so if you look at the formula, this is the formula. We inverse Laplace the f times g. Okay, f times g. So before you start to integrate, you have to find for the inverse Laplace of f and also g, because this is lowercase f, this is lowercase g. Okay, so we have to inverse Laplace both of these two separately. We look at this example. Okay, when you want to inverse Laplace this, okay, this one, if you look at the denominator function, we are unable to solve this by using completing the square. Okay, because if you expand, okay, the degree of this function is third degree. Okay, the third degree. So we can't use completing the square. Okay, completing the square is for second degree. So this kind of question, okay, we have to inverse Laplace using convolution theorem. So this one, we will separate it into f and g, okay, into f and g. So this is actually 1 over s squared times 1 over s minus 2. Okay, just means this one, this function multiplied to this function, we get this. Okay, so 1 is for f, 1 for g. So now we inverse Laplace this 1 over s squared, we get t. And if we inverse Laplace 1 over s minus 2, you get e to t. Okay. And according to the formula, this is fu, not ft. Okay, fu. And this is gt minus u. So for the function of f, we need to change the t into u. Okay, according to the formula, we change t into u. So all t we change into u. And for the function of g, this is t minus u. So we change the t into t minus u. So all t change into t minus u for the function of g. Okay, and after that, this fu multiplied to this gt minus u, that means u multiplied to this exponential function, and we put it into the integral. Okay, we are integrating this function from 0 up to t with respect to u. Okay, with respect to u from 0 up to t. So this is polynomial, this is exponential function. So we will solve using either integration by parts or tabular method. Okay, tabular method. So if you use tabular method, you will get this. Okay, you will get this function. Okay, this one you put under differentiation, differentiate u until you get 0. And this function you put under integration and you integrate twice with respect to u. Okay, with respect to u. Okay, then you get this from the tabular method. Okay, now we are substituting the t into the u. Okay, t into the u, and then minus the substitution of 0 into u. Okay, we are substituting into u, not t. T into u minus 0 into u. Then you get this result. Okay. So now since we are separating this into two, one is f, another one is g. So how do we choose which one is f, which one is g? Actually, it doesn't matter which one is f or g. Okay, but if you want to have a simpler word, okay, we would tend to choose the simpler one to be g. Okay, the simpler one to be g, because later on we will need to change gt into gt minus u. Okay, we will tend to choose the simpler one, simpler function to be under g. Okay, another one will be f. So for example, if you have after the inverse Laplace, you have one t, another one is cos t. For sure, the one cos t you will put under this. Okay, because cos t, and later on your t will be changed into t minus u. It will be even complex, okay, a little bit compared to the f. Okay, so in short, we will choose the simpler function to be g. Okay. Now I want to show the steps here on whiteboard, and after that, followed by the exercise. Okay, this is from the example. Okay, so this one is the tabular method. U as the polynomial function put under D, and the exponential function e2t minus 2u. Okay, so when we differentiate this one, and then again we get 0 plus minus plus. This one, when we integrate, we get the same function over 2 or -2. We are integrating with respect to u. So -2. So integrate once again, you get a 4. Okay, so now we have -1 over 2u e 2t minus u minus 1 over 4 e 2t minus u. Okay, 0 up to t. So when we substitute t into u, t minus t is 0, e0 is 1. U, you substitute t, so you have -half t. Okay, t into u. So t minus t is 0, e0 is 1. Then minus 1 over 4. Okay, here also same, t minus t is 0, e0 is 1. So you get this. Minus the substitution of 0 into u. Okay, so when this u is 0, you get 0. And here you have minus 1 over 4. E, u is 0, so you have 2t. 2t. What do you have? You have -3 half t minus 1/4 plus 1/4 e to t. Okay, so this is convolution theorem. Okay, convolution theorem. So now we try the exercise. We try the exercise. This is from the example. Okay, this is from the example. Exercise. Number 1, inverse Laplace. To integrate the f and g. Okay, but first you need to write down what is your f and g. Okay, so 1/s+1 and 1/s-2, both of these two, you get an exponential function. Okay, so it's no difference whether this is here or here. Okay, because both of these two functions, after you inverse Laplace, you get the exponential function. Okay, so ft, what is your ft? E negative t. Okay, this one is e to t. So this is fu. This is gt minus u. Okay, so fu means you change the t into u. And gt minus u means you change the t into t minus u. Then in the integral, we have fu times gt minus u. That's really this one times this with respect to u. Respect to u. Okay. So before you integrate, you can combine two e's into one. So what is the new power? The new power? You have negative u plus 2t minus 2u. So 2t minus 3u, right? This is the new power. So 2t minus 3u with respect to u. Okay, up to this point, okay? This one? This one, 2e combined into 1. So we just sum up the power. Then give you, this is 2t minus 2u, we sum them up. Then you get the power. Okay, then we integrate exponential function. You get the same function back over. And we say 3 because we are integrating with respect to u. Okay, 0 up to t. So, okay, let's say we factorize -1 over 3. We just substitute the t into this exponential function. So you get e t into u 2t minus 3t. Okay, minus 0 into u.
Minus t to t.
Yeah, 2t. Okay. Any questions? So this question, actually you can solve using the completing the square, because when you expand, you get s squared. When it is in second order, you can either choose to expand and then use the completing the square and then apply the first translation, or you use the convolution theorem. Okay, actually it depends on the question. If the question mentions that you have to use the convolution theorem, then you have to use convolution theorem. If it doesn't state any method, just evaluate. Evaluate this one. You are free to choose any method that you want. Okay, number 1, any questions? If no, we look at question number 2. So we have 1 over s squared. Okay, we have 1 over s squared. When we break this into 2, 1 over s squared, another one is 1 over s squared plus 4. So which one you want it to be fs? Which one? Actually, it can be either one. Okay, but if you want to have an easier word, we will tend to choose this one. Okay, this one here, and this one here. So what is this? When you inverse Laplace this one, what do you get? Sine. Before sine? 1 over 2 sine 2t. Okay. Another one, this one, t. So we have fu and ft minus u. So for fu, you have sine 2u. And for t minus u, you have t minus u. Change the t into t minus u. So you can imagine if you choose 1 over s here and 1 over s squared plus 4 here, then this function, your function will be half sine 2 in the bracket t minus u. It will be complex compared to this. This one is easier. Okay, easier for you to do the integration. Yeah, we have 1 half sine 2u times t minus u. Okay. We simplify. It is simplified. We factorize the half. Okay, t minus u, we put it here, t minus u, and then sine 2u. So that we have a polynomial times sine function. Okay, polynomial in u, sine in u. So when we do the when we solve the integration, you have to apply. What technique to apply? Polynomial and sine. Tabular. Tabular. T minus u and sine 2u. Okay. So when you differentiate, what do you get? When you differentiate this one with respect to u, remember with respect to u. And this one integrate, you get a negative cos 2u over 2. And here negative sine 2u over 4. Negative half t minus u cos 2u. Minus, 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 we get minus 1 over 4 over 4 sine 2u. 0 after t. Okay. Now we substitute the t into u. T into u. So t minus t, 0. Okay. Minus 1 over 4 sine 2t. Okay, the bracket minus substitution of 0 into u. Okay, into u. So cos 0 is 1. Okay, cos 0 is 1. When u is 0, you have t. So negative half t. Sine 0 is 0. Simplify. Positive half t minus 1 over 4 sine 2t.
Yeah.
Okay, any questions?
We hit the half side.
Sine 2t. This one. Inverse Laplace. Inverse Laplace this function. This is a square, so you need a 2. Multiply the 2, divide the 2 outside. Attendance, 11 times attendance. That's number 3. Okay, number 3. What is your F and G? X over this one multiplied to this one, right? S times S, you get S squared. This one multiplied to this, you get this squared. Okay, that's been both of these F and G, they are the same function. So what is the output of inverse Laplace? Cos t. Cos t, both are cos t. And this is fu. This is gt minus u. Okay. Now we put the ft and gt minus u into the integral. Cos u and cos cos u and cos t minus u du. Okay, how to integrate cos times cos? Let me check whether your appendix has the IVP. This one we have to change. Okay, the identity is given in the final exam appendix as this. cos x plus y equals to cos plus and minus. So you can get this from the appendix of any of the past year. Okay, normally the appendix is the same across the years. Okay, so here we want to use this, okay, to change this one into something like this. Okay, a cost function plus another cost function. We do not have 2, so we move the 2 to the right. Okay, we move the 2 to the right. Meaning that here we have cos x times cos y equals to half cos x plus y plus cos x minus y. Okay, we will use this formula. We will use this identity to change this. Okay, so now your your x is u. Your y is t minus u. Did you see that? This is your x. This is your y. Cos x times cos y equals to, okay, we change this. Okay, we factorize the half. Factorize the half, and then we have cos. What is x plus y? What is x plus y? T. Okay, x plus y, you get t. Plus another one, cos x minus y. What is x minus y? X minus y. T minus 2.
T plus T.
X minus y. X minus y means u minus t minus u. So what do you have?
Minus T.
2u minus t. Okay. So now we can start to integrate. Cos t, we get Are you sure? Are you sure? We are integrating with respect to u. So what do you have? That means this is a constant. 0, that means differentiation. We are doing integration. Integration. That means u cos t, right? U cos t. Okay. Plus this one. Okay, this function, there is a u here, so we are integrating cos. We get sine with the same angle over 2. Okay, respect to u. Okay, 0 up to t. Now t, we substitute into u. So t cos t plus, this is 2t minus t, you get t. Minus 0, substitute into u, 0, and then 0 into this, you get sine negative t, right? Plus half sine negative t. T cos t. What is this? Negative sign. So we can bring the negative outside here, right?
Yes.
So this is minus. So minus, we get a plus, right? We get a plus. Half plus half, 1. Okay, any questions? Any questions? No? If no, then I continue to the exercise 3.13. Okay, exercise 3.13. That is asking you whether you know how to choose the suitable suitable method or suitable properties to solve the inverse Laplace. Can I wrap this up?
Yes. So,
Exercise 3.13. Okay, number 1. Okay. The question is, find the inverse Laplace transform of the following expression. Okay, that means without mentioning or specifying any method, you are free to choose any. Okay, you are free to choose any method to solve this. Okay, so if you look at this one, so what should you use? Huh? Which method you use? We haven't signed for your attendance, anyone? So this one, you have to use the completing the square, right? Completing the square, because this is a quadratic equation, the quadratic function. So s squared minus s minus 2. Complete the square. Complete the square. So what do you get? S squared, you get an s. Then minus, what is the value here? 1. 1. The value here is 1, right? The value here is 1 minus 1. Okay, minus 1. This value is divided by 2. Divided by 2. Okay, then minus the square of this. The square of this. So 1 over 4. Then continue. Minus 2. Okay, simplify. S minus half square minus 9 over 4. So you put this back into here. S minus half square minus 9 over 4. This is 1. So next you apply. What we apply? What we apply? Okay, what you need to do next? What you need to do next? You need to take out the negative half, right? We want to take out the negative half, so we have an s squared minus 8 squared, correct? To take out this minus half, you have to apply the first translation. First translation. So once you take it out, you have e. This negative half, this will be positive. t. Okay, once you take it up this minus half, you get e positive half t. So what is left in the bracket? You have only s squared minus 9/4. Okay, next we want to inverse Laplace of this function. So this is hypersine minus, and there's no s at the top. So this is hypersine. But if you want to inverse into hypersine, make sure this is a squared. So what is your a? What's your a here?
9/9.
3 over
2.
2. You need a 3/2 here. So when you multiply a 3/2 here, here will be 2/3. 3/2 over s squared minus 9/4. So this is hypersine. Okay, hypersine. Hypersine 3/2t. Okay, so if you look at the final answer that I gave in the slide, the answer is -1/3 e negative t, and plus 1/3 e to t. Okay, the given answer in the slide is this one, but here what we get is this, but actually these two are the same. These two are equivalent because for hypersine and hypercos, actually they have the formula in terms of exponential function. Okay, so if you refer to the appendix, there is the difference. Oh, not listed in the appendix. Okay, hypersine 1, hypersine x is ex minus e negative x/2. Okay, this formula is not given in the appendix, but it doesn't matter. You can leave your answer in this form. You can leave the answer in this form. I just want to explain why you see a different answer in the slide, because if you solve using partial fraction, okay, if you solve this question using partial fraction, you will get this. Okay, if you solve using the first translation, you get this, but actually they are the same. Okay, the one for cos is plus. Okay, the one for cos is plus ex plus e negative x/2. Okay, so how to get this from here? You just substitute this one. Your hypersine 3/2t, right? So you just change the x into, x into 3/2t. So this one, let's say you want to check whether they are the same. So this function, okay, this function will be changed into this. E, the x is 3/2t minus e negative 3/2t. Okay, so you just multiply, simplify, you get this. Okay, this one I leave it to you. Now we get 3/2. This is a squared.
Yes.
A squared. So your a will be set of 9/3. This means square root of 9/4 is 3/2. Square root.
81/16.
81/16. That's mean 9/4.
Yes, so let's do square.
No, not square, it's square. This is a square. This is a square. So square root this, you get this one. Okay. Next, we will get question number 2. Any questions? Any more questions for number 1? Okay, number 2.
CVT.
So this one, we have to complete the square. We have to complete the square for this s squared plus 2s plus 10. So what do you get here? S squared, we get s plus 2 here, plus 1. Okay, close the bracket, square, minus 1. Square of 1 is 1. Then plus 10. So you get this s plus 1 squared plus 9. Okay, substitute this back into here. Okay, once we have settled the bottom function, okay, now we look at the function at the top. You have an s here. Okay, later on, we want to take out the plus 1, right? We want to take out the plus 1 so that you have s squared plus 9. So in order for you to take out plus 1, you have to make sure all s are in the same form, s plus 1. So this s, you have to create a plus 1 for the s. So 3s plus 2. Okay, 3s plus 2. So the s, we have to create the plus 1, but of course, we don't change the question. Plus 1 minus 1. Then, now we can take out the plus 1. Okay, you can take out the plus 1. After you take out the plus 1, you get an e negative t. Negative t. So once you take out the plus 1, you have 3s minus 1. Okay, 3s minus 1 plus 2. Here, s squared plus 9. Okay, simplify, separate, inverse Laplace. Okay, simplify. Minus 3 plus 2 minus 1. Okay, minus 1. Then you break this into 2.
How we get the E minus
E minus t. Okay, according to the Okay, this is the formula for the first translation. First translation. When we Laplace this, we get this. When you take out a minus a, you get this.
So this was
A is -1.
Yes, a is -1.
Is the one with S, right? The one with S. The S minus A. So this minus B. Yeah.
This one, it's really s minus a. All s must be in the same form of this f minus a.
So this formula we're gonna memorize it or
No, the formula is given. The formula is given. It's just that you need to know when you have to use it. Okay, so this one. Okay, what is this? What is the answer for this one in this last class? 3 plus 3t. And what about this? Minus, you need a 3 here, so you have 1 over 3 outside. And the answer for this is sine 3t. Okay, any questions?
okay, all of the Laplace of formulas is T by all time. We're gonna give it.
Come again?
The Laplace formula. All of it, we're gonna give it.
All formulas.
This by T. Yes, it's by T. This by T. Laplace table.
Laplace table, yeah. Laplace table will be given. Okay. Now we look at number 3. Okay, number 3. How to solve this? S to the power 4. S to the power 4. How to solve? Any idea? Huh? Okay, this one, we have to factorize, right? We have to factorize s squared, so that you have s squared plus 4. So when you factorize, after you factorize, you will see that we have to use convolution theorem. Convolution theorem, okay, because of s power of 4. If this is s squared, okay, if this is s squared, that means we use the completed square. We apply the first translation. Okay, but if this is not 2, then you have to use the convolution theorem. Okay. Or if it is the one that you can find from the table directly, then just use the table. Okay. Otherwise, okay, convolution theorem. So this one, if we want to solve using convolution theorem, you have to break it into Fs and Gs. Okay, what is your Fs and Gs? How would you want to separate this? F is 2 over s squared plus 4. Gs is 1 over s squared. No longer 2. If you have 2, you get a 4 here. Okay. So ft, this is sine 2t, and this one is t. Okay, fu will be sine 2u. So you put this into this formula, okay, sine, that's mean t minus u, sine 2u with respect to u. And this is polynomial, this is sine, so we have to use the tabular method. Okay, tabular method. I'm going to put it here. T minus u and sine to u. Okay, differentiate t minus u with the okay. To u, you get a negative cos to u over 2. One more time, you get negative sine to u over 4. A negative half minus plus 1 over 4 sine to u. We are differentiating with respect to u. Yeah. If you take one. Okay, so this is the minus one. Substitute t into u, t minus t, 0. Minus 1 over 4 sine to t. Okay, minus the substitution of 0 into u. Okay, cos 0 is 1. When u is 0, you have t. So minus some t. Sine 0 is 0. Okay, so you get this. Positive half t minus 1/4 sine to t. Okay, any questions? Now we look at the last question. Okay, question number 4, any idea? Factorize. This is already in the, it's already factorized. Any idea? Huh? How to start? What property you have to apply? Which one? Which property you have to apply? Okay, whenever you see s minus a in the bracket to the power of 2, 3, 4, 5 and above, use first translation. Why we use first translation? Once you take out this minus a, you have s cubed, right? S cubed, that means you can choose the one t to the power n. T to the power n, you have this one. Once you take out this minus a, you can choose this. Okay, it is possible to choose this to carry on. So if you want to use the first translation, what is the first thing that you need to do? Before you take out the -1, make sure all s in the same form, right? Including this.
-1
So s squared, that means s -1 plus 1. Then you take out the -1. If you take out the -1, you form E. One T. 1T. S minus A, this is EAT. Okay, so ET, what do we have here? S plus 1 squared over S cubed. Okay, as long as we have settled the bottom part, the upper part is not an issue because we can factorize, we can simplify. Okay, we expand and then we separate them, okay, into 3. So when you expand, you get s squared plus 2s plus 1, right? Then you break this into 3. So this one, you get 1 over x. This one, you get 2 over x squared. This one, you get 1 over x cubed. Separate them, simplify. Then we get the final answer. Okay, 1 over x is 1. 2 over s squared is 2t. 1 over s cubed. Okay, this one n is 2. Okay, n is 2. We need a 2 factorial. 2 factorial is 2. So we need the 2 here, meaning that we divide the 2 outside. So this is t squared. Okay, n is 2. t squared. Any questions? Any questions? Okay, remember this, whenever you see s minus 8 in the bracket to the power of an integer, okay, use first transformation. Okay, but before you take out the minus 8, make sure all s is in the same form of s minus 8. Okay, next. Now you have learned the Laplace transform and inverse Laplace transform. Now it's time for you to see how you apply this Laplace and inverse Laplace to solve a differential equation. Okay, there will be one question in your final exam. Okay, on how to solve a question something like this. This is an example. You see, this is a second order differential equation with initial values given. So you can use Laplace transform to solve and get the answer. But of course, this is a homogeneous differential equation in second order. You can use the characteristic equation, right? You can apply characteristic equation to solve this question. Then after that, apply these two given initial values to get a C1 and C2. Okay, so if you use that method, you will get the same answer, sine t. Okay, you will get the same answer. And now we are looking at how to solve this using Laplace transform. Okay, if you use Laplace transform to solve a differential equation, the initial values must be given. Okay, the initial value, this one must be given. Okay, now we look at this one. Okay, let's say we look at. Now we look at this example. Okay, so to solve this, okay, look at here. To solve this differential equation, we have to Laplace transform every single term. We have to Laplace x double prime, Laplace x, Laplace 0 to form the equation. Okay, so when you Laplace, you see this one, this is what you haven't learned. Laplace derivative. Okay, Laplace derivative, x double prime, x prime. How to Laplace transform? Okay, this is the formula. This is the formula. Okay, for Laplace transform of the derivative. Okay. So if you look at this one, y in the bracket, the one n in the bracket means the order of the derivative. If we have y double prime, it means n is 2. Okay, if y prime, that means n is 1. Okay, so when you Laplace this derivative, this is the formula. Formula is given, but you have to know how to come up with the function. So n, we will start from this s to power n. Okay. So now let's say we want to Laplace transform y double prime. Okay, y double prime. So according to the formula here, s squared, we will start from s squared, and then s power of 1. And next will be s to the power of 0. Okay, power 2, power 1, power 0. And the last term, it will be the one without s. That means s power of 0, then we stop at the term. Okay, we stop at the term with s power of 0. And the first term, okay, the first term, here after s, this is in capital. Okay, capital, if this is y, then this is capital Y. If this is x, this is capital X. In S. Okay, in S. Okay, the one, next one, it will be lowercase. Lowercase is 0. Okay, lowercase of y is 0. Okay, and next one, it will be y prime, y double prime, y triple prime. Okay, so if you look at this example, I don't know what's wrong with this project. Okay, double prime. Double prime means n is 2. Okay, double prime means n is 2. So we will start from s squared. Okay, s squared, s power of 1, and then s power of 0 is 1. So we will stop at this term. The 1 s power of 0, we will stop at this term. Okay, and the first term, it will always be in capital. So this is y, so we have capital Y in S. Okay, capital Y in S. The next one will be lowercase of y in 0. And next will be y prime. So if you have one more term, after that, it will be y double prime. Okay, y in capital, y lowercase, and then y prime, y double prime, and so on. But why we stop at this y prime 0? Because this is s power of 0. Okay, s power of 0. And write on the board. That much y double prime. y double prime, that means n is 2. Okay, n is 2. So we will start from s squared. Okay, s squared. And the first term is capital Y in x. Okay, it will be always capital in x. Okay, minus s squared. Next one will be s power of 1. Okay, s power of 1. And then the first is in capital. The second one, starting from the second one, it will be lowercase y0, y in 0. Okay, minus, okay, s power of 1, next one will be s power of 0. S power of 0 is 1. So normally we won't write s power of 0. Okay, and this y next will be y prime. Okay, now we look at how to Laplace transform for y prime. Okay, y prime. 1 prime. That means n is 1. N is 1, that means we start from s power of 1. And the first one is capital Y in x. Okay, minus this one, next one will be s power of 0, which is 1. Then we stop at the second term. So y next will be lowercase of y in 0. So you have only 2 terms. Okay, now plus y only. Y only, we know that this is y in x. Just like Laplace t, right? You have learned this Laplace, Laplace f. Okay, Laplace f function in t, you get fx. Same as this. Okay, because this is not derivative, no prime, no derivative. This is not derivative. We just Laplace directly like this. Okay, so if you have, let's say I give another example in degree of 4. Okay, degree of 4. Laplace y 4 prime. Okay, with 4 prime. So n is 4. So s power of 4 capital Y in x minus
S power of 3.
s power of 3. Okay, y in 0 minus s squared y prime in 0 minus s y double prime in 0, then minus s to the power of 0, then we will stop at this for the last term. Y prime in 0. Okay, so you see, when this is order of 4, you have s to the power of 4, 3, 2, 1, 0. Then we stop at the term s power of 0. And the one, okay, after s, you have the first term is capital Y, okay, the one in capital in s. The rest are lowercase of y in 0, okay, y in 0. Okay, but the second term is y. Next will be y prime. Next, y double prime, y triple prime, and so on. Okay, this is how we Laplace transform a derivative. Okay, a derivative. Okay, now we look at the example. Okay, this is example in the slide. Right on the whiteboard because of the projector. Maybe the projector or the table. Okay, this one, we will Laplace every single term. Okay, every single term, meaning that we will Laplace x double prime plus Laplace x equals to Laplace 0. Okay, this is from example, so you don't have to copy it. Okay, you don't have to copy. So x double prime, right? So s squared x will be lowercase of x in 0, then minus s to the power of 0, okay, so x prime 0. Okay, so this is for the first term. Now Laplace x. Okay, Laplace x. This is not a derivative. So this is x in s. This is not a derivative. And Laplace 0 on the right, you get 0. Okay, Laplace 0 is 0. Now we substitute x0 into here. This value, x0 is 0. X prime 0 is 1. So if you simplify, you get this minus 0s minus 1 plus xs equals to 0. Okay, after you substitute the initial values, okay, you simplify, you get this.
You can take the one out. One.
Then on the left, we want this. On the left, we want x in s. So these two, you factorize the x in s. Okay, when you factorize, you get this. The one without x in s, you move to the right. Okay, you want the xs to be on the left. So this one and this one, you factorize the x in s, so you get s squared plus 1. This term moves to the right. Okay? Up to this point, okay?
How the s squared plus 1?
From here, this is s squared xs plus xs minus 1 equals to 0. So from these two, you factorize. Factorize the xs, so you have s squared plus 1. Factorize. Just like x squared y plus y. You factorize the y. Okay? Then the one without xs, you just move it to the right. Okay? Now we want only this on the left. We want only this. That means this one we will move to the right. This is multiplication. This one multiply x. So when we move, it will be divide.
S squared.
Okay, division. Then to get the x in t, we apply the inverse Laplace. Right? We apply the inverse Laplace. So this one we get a sine t. So we get a sine t. Okay, so this is the final answer. Xt is sine t. Okay. Okay, now we look at the second example. Okay, second example, where the right hand side is no longer 0. Another example. Now we need to Laplace every single term. Okay, Laplace x prime minus 2 Laplace x equals to Laplace t. Okay, now Laplace x prime. X prime n is 1. N is 1. So you have s power of 1 capital X in s. And minus s power of 0, which is 1. This one after that will be lowercase of x in 0. So this is for this first term. Why we stop here? Because this is s to the power of 0. Whenever it reaches s to the power of 0, then we stop. Next, minus 2. This is not a derivative, so you just give a capital X in S. Okay, what is Laplace T? Laplace T is 1 over S squared. Okay, now we substitute this given initial value. This is 0. Okay, so we have only these two terms on the left. We factorize the X in S. So what do you have? What do you have?
We have S minus 2.
X minus 2 equals to 1 over S squared. Okay, remember we want only X in S on the left. So this one, bring it down. Okay, bring it down. So you have this S minus 2. So to get the final answer, X in T, we have to inverse Laplace this function. You have to inverse Laplace. So how to inverse Laplace this?
Separate to 1.
Separate. That's mean you use. What is the name? Convolution theorem. So now you see, you apply what you have learned for the Laplace transform here. Once you get the X in S, you apply what you have learned for the inverse Laplace to get a final answer.
Yes.
So to solve this, okay, what is your Fx? What is your Gx?
1 over S 1 over S minus 1 over S minus.
Okay, your Fx will be
1 over
1 over S squared. Okay, or you want to have 1 over S minus 2. Okay, I will choose 1 over S squared here and minus 2 here. Okay. Will be E to T. GT will be T. F U will be E to U. GT minus U will be T minus U. So to solve this, we integrate from 0 up to T. Then we have T minus U, E to U, BU. Then, how to solve the integration? How to solve the integration? Tabular method. Tabular, where should I put my put here? Okay, T minus U and E to U. Okay, so differentiate respect to U, we get -1 and then 0. This one we get E to U over 2. E to U over 4. Okay, then come back to here. We have positive half for T minus U. E to U minus okay, plus 1 over 4 E to U 0 up to T. Okay, so now T substitute into U, T minus T 0. This one plus 1 over 4 E to T. Okay, minus 0 into U half T. E0 is 1 plus 1 over 4, E0 is 1. Okay. Then you get this. Any questions? This is from example from the slide. Okay, this is an example from the slide. The second example. Okay. Any questions? If no, I try the exercise. Laplace transform every single term. This is exercise 3.14. Laplace transform every single term. Try to Laplace these three terms. Yeah, that's what we get the same answer. Yeah, it's specify solve this differential equation using Laplace transform that you have to use Laplace. I mean, to make sure people answer. But actually, for differential equation, once you get the answer, you can double check whether that is the correct answer by differentiating the function and substitute into the derivative, and this x, you will know whether your answer is correct. Just like the question just now, the example just now is. Example just now is x prime minus 2x equals to t, right? And then this is the answer. This is your xt. This is the xt. So if you want to know whether your answer is correct, you just substitute this x into here, and you differentiate one time. You substitute into here, and see whether you get a t. If yes, then the answer is correct. Okay, class, I want to remind you that if you want to check your answer, whether your answer of the differential equation is correct or not. For example, this is the differential equation. Okay, and after you solve, okay, this is the answer for xt. So you just substitute this xt into this x, and you differentiate one time with respect to t, you get x prime, and you substitute here, and you see whether you get this t. If yes, then your answer is correct. Okay, this is how you check your answer. Okay, so after you have done solving the differential equation, If you have time, you can double check whether the answer is correct. Okay. Just substitute the x and x prime. You just solve the left hand side, see whether you get the right hand side. Okay, very simple one. Okay, that's double prime. Double prime, that means s is 2. So you have s squared. And then capital X in s minus, it will always be minus. Okay, if you look at the formula, there are always minus. Then s
X1.
lowercase of x in 0 and
Y, XY.
x prime in 0. Okay, this is for the first term. Okay, class 9. Class 9, this is not a derivative. So we just put in this form. Okay, Laplace, you get this. And the right hand side, Laplace 0 is 0. Okay, then we substitute the x0. x0 here is 3. X prime 0 is 4. Okay, so we have s squared, x in s, plus 9x in s. This is minus 3s, minus 4. Factorize the x in s and move those without x in s to the right. And then move those without x in s to the right. Next, we want only x in s on the left. We want only this on the left. So this one goes to the right. Then your answer should be x in t. So now you can apply, you have to use the inverse Laplace to find the answer. Okay, inverse Laplace. So from x in s to x in t, you need to apply whatever you have learned for the inverse Laplace. Either the first translation or convolution theorem or just direct inverse Laplace according to the table. So the answer is three cos 3t plus plus 4 cosine. You need a 3, right?
Yeah.
Do not forget about the a here. You take out the 4, you need an a here. The a is 3. When you insert the 3, divide the 3 outside. So this is sine 3t. Okay, any questions? Any questions? This is the most simplest one. Okay, the most simplest one because the right hand side is 0. Okay, if you look at the past year question, normally they won't give 0 on the right. Normally, okay, because this is the simplest one. Okay, I think we continue next class. Okay, continue next class. You can try first. So, I'll see you this Friday. And next Monday is your midterm. Okay, midterm. So I will the Jordan was NTC, the Maths Tutoring Center, and will hold something like a revision class for the midterm this way. And later on, they will release the date, okay, the date and time. But for this differential equation, okay, I have choose the date of this Friday afternoon because there is no available time slot for me to accommodate section 1 and section 2. So the only free time for all of the students are this Friday, 3 to 5. Okay, this Friday, 3 to 5. This is not compulsory, okay, not compulsory, but for those who want to attend, you just attend, just like the engineering class 1. The planning will be announced later because I'm not sure where the sign.
So it's more
Face to face.
face to face.
Face to face. Yeah. But because okay, so it will be face to face. It's some revision class, but I will also record the video. Okay. Okay. See you this Friday.
I think sometimes we